So today we're going to look at slope of a line. So you can find slope of a line a few different ways. If you know 2 points, if you know just the 2 points on the line, then you can use, so let's just say we've got x1, y1, so we know that 1 point, and we know x2, y2 here. We know the second point. So we can say y2 minus y1 all over x2 minus an x1. Okay. So that is slope. So you could also change that equation to y1 minus y2, but the denominator would have to be x1 minus x2. So you can switch that. So if I wanted to find the slope here, between -2, 4 and 3, -5. So if I want to find the slope, then I would say -5 minus 4 all over 3 minus a -2. So this is a -5 minus a 4, which is a -9, and then this is 3 minus a -2, which turns into a plus, which is going to be a 5. So my slope here is going to be -9 over a 5. Okay, so it's negative, so that means that it's going to be falling, right? So the other way that you can do it is looking at a graph. So let's just kind of look. The slope is going to be your rise over your run. It's the slope here. So just looking, I'm not going to draw any points here, but I'm just going to kind of, but if I were to increase from left to right, that's going to have a positive slope. If I decrease from left to right, I'm going to have a negative slope. So the slope would be negative. If the graph has no change like this and goes through the y-axis, then the slope of this graph is just going to be a 0. And if it is a vertical line straight up and down, this is going to have a undefined slope. Okay, because the 0 is actually going to be the change of the x's is 0, so that's going to be in the denominator. Alright, so it's rise over your run. Okay, so let's look at one that we did the other day. So here, if I were to look at this one is decreasing from left to right, so it would be a negative slope. So let's look at the change here from these 2 points. So from here, I'm going to count, I'm going down. 1, 2, 3, 4. So it's going to be a -4 and a 1, 2, positive 2. So that slope is going to be a -4 over a 2, which is going to be a -2 slope. Good deal. Okay. You can also look at an equation. So if you were to look at an equation, the linear equation would need to be solved for y. So if it was solved for y there, then you can find the slope. It's going to be the value that's in front of your x. So a lot of times our equations are in standard form. So here is an equation that's in standard form. Standard form just means that the x and the y are on the same side. So if I wanted to find the slope here, I would need to solve this equation for y. So I'm going to move the 2x to the other side. So when I move the 2x to the other side, it becomes a -2x. And then I am going to divide everything by a -4. So here I'm going to have negative 2 divided by negative 4, which is a positive 1/2. 8 divided by negative 4, which is a negative 2. So the slope here is going to be a positive 1/2. So that means that this graph is going to be increasing from left to right. The B there is going to be your y-intercept, so that could be used for graphing, which we're about to talk about. Okay. All right. So let's look at how to graph some linear equations. So you can graph your linear equations using your x and y intercepts, which we did yesterday. You could use the y-intercept and the slope, so it has to be, it would be in this form. Usually if you were to find the x and y intercepts, it would be in the standard form. Like this. This is standard form here. And then to choose 3 or more x values, it doesn't matter what format it's in for that one. Okay, so remember your domain of a linear function is all real values, so that's why you can choose any x value that you want to plug in. So let's try this one here. So I've got 2x plus y equals f4. So if it's in this form here, 2x plus y equals 4, the best way to do this one would be probably using your x and y intercepts. So the x-intercept here is going to be when I let y equal 0, right? So it's going to be 2x equals a 4. So x is going to be equal to a 2. So the x-intercept is 2, 0. The y-intercept is when I let x equal 0, so it's going to be y equals a 4. So this is going to be, the 0 would come first, not the 4. 0, 4. Some graphing paper right here. So we would then just plot those points there. So 2, 0 and 0, 4. And then I don't have a straight, oh, I do. This is my life right now. I can never draw a straight line. Y'all will see that later. And I couldn't even do it then. But then you would just connect your 2 points there. Okay. Let's do another one. So let's graph. Let's graph this one. I'm going to graph this one 2 ways. I'm going to graph it by using the y-intercept and the slope, and then I'm going to choose some x values and solve for y to show you that as well. Alright, so the y-intercept, remember the y-intercept is an ordered pair, so the y-intercept is 0, negative 5, and the slope here is a negative 1/2. So this is rise over run. So what you're going to do is you will plot the y-intercept. So I'm going to plot the y-intercept, which is a 0, negative 5. So I'm going to go 0 down here to negative 5. And then I'm going to use the slope to find another point. Okay, so the slope is not a point. The slope is the change of the graph. So I'm going to use the slope to find another point. So it is a rise of a negative 1. So that would mean I would go down 1, and then I'm going to run over to the positive direction 2. 1, 2. And there's another point. You could also rise up. So you could rise up 1, but it has to be a negative, so then it would have to run in the negative direction. So it'd have to run 1, 2 in the negative direction. And you could keep doing that, finding your point. So rise up 1, over 2. Rise down 1, over 2, just like that. And see how many points, because remember it's a continuous graph, so your linear equations are continuous. They're going to continue to go in both directions here. So that's what it's going to look like. Okay. Alright, so now I'm going to take that same graph. So this is going to be my third way. I'm going to take the same one though, just to make it a little easier. And I am going to choose some x values and find y values. Usually we try to choose 3. You could choose 4. Okay, 3 just kind of helps you see what the graph looks like, especially when we get into something that's not a linear equation. All right, so I like to choose 0, so I'm going to choose 0. I also am going to choose a -2. And why am I going to choose a -2 and not a 1 or a -1? If I choose a -2, I plug it in for this x right here, and the denominator is going to go away. So I'm going to deal with whole numbers. If you chose a 1 or a -1, you are going to have a fraction for your y value. And that's fine because those are points in the graph, which is completely okay. But just makes your life just a little bit easier not having to graph fractional points. So then I'm going to plug in a +2 as well. So if I plug in a -2, so I'm going to have a -1/2 times a -2, that's a -2/1, minus a 5. So this becomes a +1, so 1 minus a 5 is a -4. If I plug in a 0, then my y value is going to be a -5, which that is the y-intercept. If I plug in a 2 here, so I'm going to have a -1/2 times 2, that's a 2/1, minus a 5. So it's going to be a -1 minus a 5, which is a -6. So now I'm going to plot all 3 of those points on my graph. So, sorry, trying to get this all on the same screen. So I've got -2 down to -4, 0, -5, and then 2, -6. And if you were to connect the dots here, there we go. And those graphs should look almost identical there. I kind of went up a little bit on that, so I didn't even go through that point there. Okay. All right. So the other thing that we can do is find an equation of a line. So to find an equation of a line, we need to know this formula, y minus y1 is equal to m times x minus x1. So to find an equation of a line, you need to know a point that lies on your line, and you need to know the slope of your line. So you need to know a point on the line and slope. So those are the 2 things that you need to know to find an equation of a line. Okay, after you plug in, you can either have your equation in slope-intercept form, or you would have it in standard form. So that's after you plug in. Okay, so let's find an equation of a line. So here, find an equation of a line with slope of a 2 and passes through the point 4, 5. So I know a point and I know my slope, so I can plug it in. So I'm going to have y minus y1 is equal to m times x minus x1. So we're going to plug in. We never plug anything in for that y or that x. So it's going to be y minus y1, which is a 5, is equal to m, which is a 2, x minus x1, which is a 4. So now that's the formula that you will use, and then you will simplify here. Oh, and I'm sorry, let's put it in standard form. Sorry. So here I would have y minus a 5 is equal to 2x minus a 8 here. I'm going to move the 5 over to the other side, so I'm going to add 5 here. So I'm going to have y equals 2x minus a 3. This would be slope-intercept, right? Slope-intercept form. But I want to put it in standard form, so that means I'm going to move the 2x to the other side. So it's going to become a negative 2x plus a y is equal to a negative 3. But my a here has to be positive. Okay, so a in standard form must be positive. So instead of having a negative 2x, I'm going to multiply everything by negative. So it's going to become 2x minus a y is equal to a positive 3. So this would be slope-intercept form. I mean, standard form. I'm sorry. I was reading this right here. Standard form, slope-intercept form. So slope-intercept is easy because you're just solving it for y. Standard form, in standard form, you don't like fractions, and your value that's in front of your x cannot be negative. Okay? All right, let's do one, just one more here. Find an equation of a line. That passes through 2, negative 3, and 4, 5. So I don't know slope, but I can find slope because I have 2 order pairs. So I can find slope. So I'm going to have 5 minus a negative 3 over 4 minus a 2. So 5 plus a 3 is an 8. Can't believe I just did that. 4 minus a 2 is a 2. Can't believe I made a slope that was a reduced fraction. So my slope is going to be a 4. And now I can say y minus y1, and I'll always go back to the original x1, y1 that I used in the beginning to find my slope. It's just what I always do, but it doesn't matter which point you use. So y minus y1 is equal to m times x minus x1, which is a 2. So this is going to turn into a positive. So I'm going to have y plus a 3 is equal to 4x minus an 8. And let's put it in slope-intercept, sorry. And then you're going to subtract your 3 here. So we'll have, oops, sorry. There you go. All right, let me know if you have any questions.